John Cunningham here. I've built this computer based off of Ben Eater's kit, as you see here. Most of the way done with it. I built all the registers. You got your A register there, B register, ALU, that's the arithmetic logic unit, and you got the instruction register. It's not doing anything right now. Here's the clock. It sends out the clock pulse, and I got my RAM module built. So, and of course I can select different data that I want to put in there. I can put in a different address. That's the address. Here's the data. I can press this and it does that. And I can change the data and reprogram it. And I've got the address register. It's feeding in from the bus, which can run from the program counter, although I don't have the program counter hooked up right now. And I've got a display. I did my display a little bit differently. I've just got it set to do hexadecimal for the full byte. Right now I've just got it running from whatever byte's on the bus. It's just outputting all the time, or displaying all the time. Or I would say it's loading all the time from the bus and displaying. Because this chip here, 74LS273 I got, I don't know if it burned out or maybe I shorted it when I was working on it, but it quit working. So I decided, well, I don't really necessarily need a register. I'll just run it straight off with the bus. But I've ordered some other ones, and whenever I get it, then this will work a little bit better. Because it'd be nice to be able to programmatically save that display in the register rather than only feeding off of the bus. Otherwise, we can't display only what we want to display. We always have to display whatever's being transferred on the bus to other things. Anyway, maybe this video's gotten a little bit too long and getting into the weeds here, but still gotta put my instruction. Well, I got my instruction register. I gotta figure out the control logic so that all these wires that I've set up to just manually select inputs, outputs, and what have you. I'd like to be able to run all that through the instruction register and actually write programs. For now, I've just got to manually hardwire things up that I want to do. So right now I've just got it set to count. So I'm counting. That's the B register's got a value of 1, and then the A register is loading from the bus, and the A and B register are being summed in the ALU, which is feeding out to the bus. So in every clock cycle, the bus gets the sum, and then the A register feeds that sum back into itself. So it's not very complicated. I didn't have to write a program to do this. I've just kind of wired it up to where it runs pretty much the way Ben Eater did. I think that's how he had it in his video. Anyway, so that's pretty cool. And I don't know what else to say. Oh, I can do subtract, so I can count down instead of up. I just got to select on the ALU, go from that input to this input, and now we're going backwards. That's pretty cool. I could also change the value that we're counting by. Instead of doing an addition of 1, we could be doing, let's see if I can demonstrate here. I'll stop the clock. We could be doing, I'm going to try to load a different value into the B register here. So I've got that number. Let's do 5. So 1. So least significant bit 1010 would be that. So that would be 5. And we will output that to the bus like that. Now it's on the bus. Now we'll input it into the B register. this, and we'll pulse the clock. And it's loaded into the B register, and it loaded into the A register too because I didn't disconnect my load signal. So now we're gonna take that load from the B register because I don't want it to continually change. And I'm gonna stop outputting the RAM, and I'm gonna start outputting the sum. And what's going on here? Now I'm confused. What did I do? Sum is not outputting. Load. Shit. Oh, it's subtracting. It was working. I forgot to subtract. Okay. I want to do addition first because that'll be easier to figure out, to see what's going on here. Alright, so we got 0 and 5. That's where we're starting. And I'll turn it on, and it should go 5, 10, 15, 20, 25, except it's going to be counting in hex, so it's going to be different. So we'll see hex numbers. 5A, A is 10, and then what comes after A? 15, which would have been F. Anyway, that happened too fast to really see, but it'll just count by, yeah, you can see it goes. We can slow it down here a little bit. See, it's counting by 5, 0, 5, A, F, and then it cycles around to 4, 9, etc., etc. So I did my display differently than Bin Eater, because I wanted to make it work with what I had, and I wanted to do hex instead of decimal, for whatever reason. That's just what I wanted to do. And so I made this clock here pretty much like the original timer clock. You can't see its speed, but it's going a lot faster. And it's only going on and off. And I've inverted back to one of these inverters we had earlier. So I'm putting alternating clock signals like on through here, and I'm ANDing the one that I want to be displayed from the EEPROM, as well as ANDing the ground of that display. Anyway, so as that clock cycles, this display turns on, and it's feeding from one part of memory, and it's feeding all zeros into the other part of memory. It's hard to explain, but I didn't have to use an EEPROM or an Arduino programmer. I did it all through dip switches here. I had to remove my switches because I only had the same dip switches that came with it. So I just programmed 0, 0, 0, 0, and then 1 through 16, or A through F, as the low half of the byte. And then I went to the other side and just programmed the high half with the other side all zeros. And so when this timer oscillates back and forth, or on and off, it's also zeroing out the half that's not being used. So ultimately what it means is I didn't have to put a shit ton of values into this EEPROM to make this work. I only had to do the high orders with the other ones all zeros, or the low with the high all zeros, and the high with the low all zeros. So I only had to put in 32, or really 31, because 0 and 0 were the same location, if that makes sense. Anyway, it's kind of cool. I haven't busted out the Arduino yet, so eventually I'll want to make something more complicated to do that. But I wanted to just make a display using hex without having to do the Arduino. So I guess that's about it for now. Maybe I'll make another video once I got something cooler to show. Thanks.